Okay guys, welcome back. So in the last video I talked about a situation in which there's friction between two surfaces when you are keeping some object one over the other, and there's friction between the two objects, as well as there's the friction between the bottom object and the surface. And what happens when you put a force, when you insert a force, or when you apply a force to the top object, what happens to the two objects, what are the accelerations and so on. So that was in the last video. Now in this video I will pose the same problem, but I will increase the force up to a certain value, and let's see what happens. Alright, so it's like this. Right, two objects are like this. So I'll take the same two masses. This mass to be 4 kilograms, so its weight is 4g, and I'll take this one as A, this is B. This mass is 10g. The normal force of this mass is Ra, and this mass is Rb, right? So this is Ra, this is Rb. Alright. So those are the forces, vertical forces. Now, if there's friction, I will take the same friction, right? Same coefficient, and this coefficient of friction is 0.25, and here also mu equals 0.2, right? So when I apply a force, I will apply a force of say 20 newtons here, right? Force of 20 newtons. Now when I apply a force of 20 newtons in this direction, this object will tend to move in this direction. Now there is friction between these two surfaces, so this object will exert a friction force so as to oppose this motion in the opposite direction. So the frictional force will be in this direction, F1, this direction, right? And for this object, now if the force exerted by B on A is F1, force exerted on A on B is also F1, but its direction is so as to oppose this according to Newton's third law. So this is F1 here. Now there is friction between the large object and this plane. So what it actually happens is that when there is friction, this due to this friction force, this object tries to move in this direction. So this plane will exert a force in this direction so as to oppose this object's movement. Right? So the friction force will be on this object F2 here. Alright? So if I am taking you can calculate Ra first. So you can put F equals ma for A. F equals ma for A. So the only force in the vertical direction, only in this direction is Ra, and in the opposite direction it is 4g. And considering that there is no acceleration on this object in the vertical direction, ma is 0. So Ra is equal to 40 if I take g equal 10. For B, F equals ma in the vertical direction. So the only force that is in the vertical direction is in this direction is Rb, and in the opposite direction, as I mentioned in the last video, it is not minus 10g, it will be minus 4g minus 10g, because 4g, this 4g force is already acting on this object, as well as this 10g is acting due to this object's weight. So what it actually happens is that the total force downwards is not 10g, it will be minus 4g minus 10g, which is minus 14g, right? 14g. And considering that the object, there is no acceleration in the vertical direction, A will be 0, so ma equals 0. So if g is equal to 10, Rb is again 140 newtons. Right? So Rb is 140 newtons. So if you take A here, the total force acting in this direction is 20 newtons, and frictional force is in this direction, which is F1, so I'm going to find F1, right? So I will find that. So Ff for A, if you calculate Ff1 is equal to mu Ra, right? Ff1 is equal to mu Ra. So mu has been given as 0.25 and Ra is 40. So this is equal to 10 newtons. Ff1 is 10 newtons. So we'll calculate Ff2 as well, so it's easy. So for B, Ff2 is equal to mu Rb, right? So Ff2 is equal to, mu has been given as 0.25 and Rb is we found 140. So 140 times 0.25 is 140 times 1 upon 4, so that will be 35 newtons. So Ff2 is 35 newtons. Right? If F1 is 10 newtons and if F2 is 35 newtons. So if you are considering A here, if you are considering A, the frictional force we found was 10 newtons in this direction. Right? If you are considering B, F1 is in this direction and F2 is in this direction. So F1 is in this direction, which is 10 newtons here, and F2 is in this direction, which is 35 newtons. Right? For A, if you are considering A, the total applied force is 20 newtons and the total opposing force is 10 newtons. So there will be a net force in this direction. So the object will accelerate. So if you put F equals ma to this object, you can find the acceleration of this object. So F equals ma to this object. So the total force must be, net force is 20 minus 10, which is 10. And the mass is 4 and the acceleration is A. So acceleration in this direction will be 2.5 meters per square second. Right? 2.5 meters per square second. But for B, what actually happens is that now the total applied force is 10 newtons and the total opposing force is 35 newtons. So this object will not have an acceleration. So A is equal to 0. So what it happens when you put some force on A, like if you keep these two objects in at stationary, and if you put some force of 20 newtons on A, is that A will accelerate in this direction. A will accelerate in this direction. Right? A will accelerate in this direction, but B will not accelerate. So B will be in this direction, like if it is fixed, right? If it is say if it is fixed by some nails or by glue or something, right? If it is like as if it is fixed, it will be in the same at the same position, but A will accelerate and go over B, like this, right? Go over B. So there will be some time t. You can calculate the time t it takes if you are given the displacement. You can put some linear equation of motion and find the time t it takes to go off B, right? So it's like that. So to find all those, you need the acceleration. So we found the acceleration now. So this is another video. So in the next video, I will be talking about another concept of friction. So thanks for watching this video and see you then.